So good morning. Uh, in this demo session, we are going to discuss about the real-time task or concept. So that were provided to one of our student, like ML assignment, and also they provided the data set also, and also prompt assignment also they have given how to solve that prompt and everything we are going to see. So using the provided data set, perform the following tasks to predict the rate based on the origin and destination. Okay. So first three different types of tasks they have given: data cleansing, correlation analysis, rate prediction. So in data cleaning, identify and handle missing values, outliers, and any inconsistencies in the data set. Okay. When it comes to the correlation analysis, determine the correlation between the variables in the data set to understand how they are related to each other. So identify which variables are most strongly associated with the rate based on the origin and destination. Even though at this moment, if you don't know about what exactly correlation, so don't worry. So during our course, we are going to learn that one. And the next one is rate prediction. Develop a predictive model to forecast the rate based on the origin and destination. Use relevant machine learning techniques and evaluate the model performance. Please use the attached data set to work on the above problem statement. So this is about the data set that they have provided. Yesterday, we have seen that. So regarding the data set, like origin, zip, destination, equipment, and this is the complete data they have given. Okay. So let's dive into the programming. So it's very simple program to develop a ML application. So why? Because so this is the Jupyter notebook. So actually I'm using Jupyter. So if I go here, so Python 3. So at this moment, you don't know about this exactly. So I will let you know everything regarding during the course. Okay. First, we need to import the important packages, import pandas as PD. So after that, so import NumPy as NP. So import matplotlib dot pyplot as PLT. Okay, alias name. Import Seaborn as SNS. So at this moment, we don't know that. So you don't know about what exactly. So even if you have basic knowledge, okay, that is good. But please stick to this session. Why? Because you don't know pandas, numpy. Even though if you don't know numpy, pandas, matplotlib, seaborn, what is meant by OS and everything. Okay, don't worry. So why? Because so just I am introducing how this ML project should be, how this basic ML project should be. That I'm giving a guidance to you before joining any course into it. Okay. So os.chdar means changing the directory. We need to go to the location where exactly our task is present. So in this folder, like in the E drive, so under Shreya task. So this is the data set that is rate based on the origin and destination that is available. I'm copying it, I'm pasting here, and I'm going to set the path manually so that I'm going to give the two backslashes. Okay. So if I execute this one, okay, it will allow me so to work on the data. So I'm creating a data frame. So where data is equals to PD dot. So read underscore CSV. So what do you mean by CSV? What do you mean by read underscore CSV? All these things we'll learn in our course. So this is the data set. Just copy the name of the data set. So how would you know that whether it is a CSV file or TSV file, as it is a semi-structured data, as we discussed that yesterday. So go here and just check the properties of it. Okay. So here, sorry, so properties. If you go and check properties here, sorry, this is the folder. Or otherwise, you can see somewhere location properties. So see here, it is a .csv file. Okay, based on that format, we need to read that one. In pandas, we are having a command called pd. So pd is nothing but alias name. So we can import pandas as our name also, but for shortcut, we are using pd. Okay, and after that, so just look at this data.head. Head will represent top 5 values if you don't specify any numerical value. But here I am giving 10. 10 means it will give the top 10 rows. Now you see that, check one by one. So here we need to study each and everything. ID, okay, ID number, origin zip, okay, destination zip, and equipment type, okay. So type 2, something called as a numerical value. Origin city, like Alsip, Lower Makefield, and Laredo, Philadelphia, so Youngstown, and Greer. So actually this is not related to the India, okay. Origin state, IL, PA, TX, PA, like that, and destination city. So from here to here, that transportation is going to happen. So destination state name, So resource rate source, like rate source one, rate source two, like that. Duration, how much it is, like in minutes, in hours, or maybe so hundreds of hours. We don't know. So the numerical value. So given as a 3 volt, but we have no information about the data. But when it comes to the real time, we will have a complete information about each and every attribute. We call these as attributes. Okay. So fields, duration, target rate, average rate, and max rate. See, we are having three different rates are there, but one of them as given as a target rate. So target rate, when we find the target as a rate, so we need to choose this one as our target variable or predicting variable. So how again we need to choose that one also is one of the important concept that we'll discuss in our course. Okay. And after that, miles, fuel surcharge. Look at this fuel surcharge. It is having all zeros are there. Okay. Created user ID. So NAN values are created at, and case date updated at. So and also updated user ID. NAN values are there. Means missing data is there. When we find such a kind of missing data, how to treat that one missing data is also he mentioned here. See that data cleansing, identify and handle the missing values, outliers, and any inconsistencies in the data. We find some inconsistencies in the data, meaning, so here we are having a lot of missing data is there, but how to find that? How many missing values are there under this ID, attribute? So we will find that one also. So first I would like to know that shape of the data. Shape will represent the size. Total number of observations are 1947. Against number of fields or attributes or number of columns. So is nothing but variables is 20 variables are there. So 20 attribute data, ID, origin zip, destination zip, equipment type, origin city, all these comes under this one. Okay, 20. So there are 20 attributes are there. Okay, then what is the next concept is any data duplicated, means repeated one more than once. We need to check that one. For that, we are going to use the command data dot. So duplicated. So dot sum will give that. If it gives one, then we need to look at that one and we need to filter that. But that concept is not using here. Why? Because there is no duplicated value is there. If we have duplicated value, we need to filter that one. So again, that is also a cleansing concept. Here, that will comes under cleansing concept. And after that, so just look at the data columns. So data dot columns. So whatever here are there, ID, origin, zip, destination. So these comes under here. So ID, origin, zip, destination, zip, equipment type, origin city, origin state, destination city, and all these things comes under the column names. Okay, there are no duplicate values. Okay, good. But I would like to know the description means, which is nothing but basic summary of statistics that I would like to know. So to know that one, we need to use data dot. So describe. So data dot describe. See here. And again, this description will give only information like count, mean, standard deviation, minimum value, 25% means quantile, 50% quantile, 75% quantile, and then maximum value. Okay. So minimum value and then maximum value. It will give only for the numerical categories. See, here we are having different types of categories are there. These are called attributes are having different types of data, right? Here it is a numerical and here it is a categorical. Okay. So like string data, and sometimes you will find a combination of it also, but actually here we can't. Yes, see that rate source one is a numerical, rate source is a category or string. It is a combination of it. We would like to know that the data type of each and every attribute also. So for that data dot, just so use the info command, will use that. See, each and everything, total range index is 1947, entries are there, records, observations, entries, and that is the thing, 0 to 1946. In Python, index starts from 0 onwards. Okay, remember that one. 0 based index. Python programming is a 0 based index. Data columns total 20, and then non-null count means how many of the attributes have complete information. Non-null means complete information. See here, ID 1947 non-null means completely filled. But some here see that created user ID and then updated user ID has a 0 non-null means no observation has filled with any value, means all are NAN values that we have seen here. See here, NAN, created user ID and updated user ID. Okay, so that is the thing. Okay, so we have knowing that data type. When you see that integer and when you see the float, these are called numerical data types. When you see the object, these are called as categorical data types. Okay, we need to treat categorical data types separately. Why? Because So there is a different types of concepts are there. We need to always my machines. Okay. So machine learning or AI or data science works only on so zeros and ones only. We need to convert them into numerical values, into numerical. So we have seen that origin city, state, origin state, destination city, and also so destination state. All these are so in what form? So they are in the object form. Object means category. Category means so like string data. So string data, so my machine won't work on the string data directly. So what we need to do means we need to convert that into the so integer data or floating point data. So for that, so we are using separate techniques are there in AI or ML. We are going to use that separate kind of techniques. But before that, so we need to check that whether we are having the missing values are there or not. Okay. So missing data is there or not. We need to check that one. So first of all, so for that, so data dot, so is NA, okay, or is null dot sum, so dot sort. We are going to use the sort underscore values where ascending is equals to false. This is called an parameter. Okay. So ascending is equals to false means descending order it is going to give. See that created user ID, created like updated user ID, updated underscore at rate source is having three missing data. So this will give the completely missing data. Okay. So all our missing data will be there means just we need to remove this one. Remove this attributes from our so data set. So how we are going to remove these attributes from our data sets? Let's see that. Okay. So we are going to use the command called data dot drop. Drop means it will remove that attributes. Here, select that attributes. So I'm going to select ID also. So because for machine learning models, which attribute is important, which attribute is not important is also a concept that is available. But at this moment, you don't know, right? So I am going to remove this updated user ID. And here, see that Python is a case sensitive. If you take any space, then it will won't delete that. So created user ID. See here, I'm selecting with space, but actually it has no space at all. See that? Okay. And after this one also, I'm going to delete that fuel surcharge. Okay. So why we need to delete the fuel surcharge? Here in the data for top 10 values, it is giving 0. Okay. Let's see that. So before this, I'm going to add insert another cell above. So here data dot so surcharge. Where is that fuel surcharge? Okay. Copy this one. So this is called pre-processing fuel surcharge dot so value underscore counts. Okay. See that 0. All 1947 observations are 0. If everything is 0, what is the need of it inside our data? So that's why we are going to remove that one also. So fuel surcharge. At this moment, I got only 4 different attributes to remove from our data. Okay. After that one, we need to use axis is equals to 1 means column wise. In place is equals to true means from that place, remove that one. Okay. So that is the thing. So here, so just execute it. Okay. So after executing it, let's take that data dot info. If you take that again information, see here, only 15 attributes are there. Okay. So 15 attributes. Previously 20 something, right? So we removed how many? 1, 2, 3, 4. 4 of them we removed. Means 0 to 15 means total 16 columns are there. Okay. So no problem. Now the next concept is filling the missing data. So actually how to fill the missing data? So that there is a different concept also. So there is some concept. I will tell you that. Okay. So missing data treatment. We call that as a missing data treatment, or otherwise we call it as a data imputation concept. Data imputation concept. Okay. And the next one is work on this. We are having two different data types, right? One is called as a numerical data type, and another one is called as categorical data type. So to fill the missing data of categorical, we use the concept called mode from the statistics. To fill the missing data of numerical, we can use the mean or median. Any one of them we can use. Okay. So what is mean, median, and then mode? Everything we are going to learn during our course. Okay. So that is the thing. So let's take that. So we are going to write here one for loop. So we can, where I'm going to take that call is equals to data dot, so columns. Okay. So data dot columns means all columns will be present inside it. So for, so I in call means, so it will, I will take that each and every column. It will go to the origin zip first. So in call, all these 16 columns are there, but I want to work on each and every column. So like on origin. So first I want to work on the origin. Next I will go to the destination. Next I will go to the equipment. Next I will go to the origin city, origin state, and all these things. Okay. So once after that one, here if, okay, so data of that column dot is NA, okay, dot sum, which is not equals to 0. If it is not equals to 0, and if again, so data of that column, so whatever the column dot D type, data type, okay, so which is not equals to, sorry, so not equals to, so here we need to select it as an object. If it is not an object, okay, so here then, so what we need to do, so we need to take that mean is equals to, so data of that column, particular column dot, so here fill NA with respect to the, so, oh, sorry, we need to first calculate the mean value of that thing. Okay. At this moment, even if you don't understand, don't worry. So our course, I will explain very clearly. So data of I is equals to, so data of I, that column, so dot, so fill NA with respect to that mean value. Okay. Meaning is so simple that, so here we are having 16 columns are there, right? We saved inside a column. So for I in column, I will go to the first column. So this one that is called as first column attribute origin zip, and it will look for here. What is the type of it? Data type. Is this object? No, right? Is this integer? Yes. So if it is an integer, and again, what are the missing values are there? For example, here 10 missing values are there. Keep that missing values as same. And how many values are filled? 1937 values are filled. If 1937 values are filled, take the average of it. Mean means average of these values, numerical values, and fill that remaining 10 values with this mean value. That is the meaning of it. Okay. So that is the meaning of this program. So don't worry. So we are going to not only work on this individual observation, and also finally we are going to work on this also. Else, in else, what we are doing means, so str means string data. So we have two different types of data, right? So one we filled with numerical values, another one is category, right? So dot mode, we need to calculate the mode, where mode is equals to, so data I dot mode, calculating the mode of that data, where data of I, so that observation, so which observation, which is a character or string data or object as type. So as type of, we need to use the str. We need to, so data dot type of str dot transform. So here again, don't worry about, so different types of form vocabulary comes. Transform, where lambda function x colon, so x dot replace, so here NaN, okay, so NaN, comma, so mode, okay. So this is the filling of missing data for category data. So how we are going to fill that one means, first we need to take that mode is equals to, here we given that if it is not an object, then it will, if it is an object, it will come to the else. If it is not an object, it will goes to here, and it will take the mean value of it, and it will fill the NA values. Okay. So that is the thing. And else mode is equals to str of data dot I of mode means, so if it is a string object, so this is the object, right? See here, rate source is having 1944 means three missing data are there. It will comes to here. And mode means most repeated value, whichever it is there, it is going to calculate and it will take here inside this variable. Data of I is equals to data dot as type of str because it is a string type format. That's why we are taking it as a str. And after that, a transform by using a lambda function means anonymous function where x will gives that each and every observation. So x means here this observations, each and every observation. So from the data. So this observation, it will go to take this as a x and it will look for that against this one rate source. If this value is filled, okay, it won't replace that with mode value. If there is a missing data here, it will fill that with the NAN value with the mode value, most repeated value. So if I execute this one, so it executed. Now see that I'm going to take that data dot info. So if I take that info again, now you see that. So all 1947 non-null objects means all missing data has been filled here. All missing data has been filled here. This is called missing data imputation. From the task one, data cleaning, handling the missing values completed. But the next one is outliers. Okay, need to work on the outliers. To work on the outliers, so there is a lot of good concept is there. So that is called as, see, in outliers, there are two different techniques are there. Many techniques are there. First, we need to check that, so whether outliers are available or not. For that, we are going to draw the different types of plots, like scatter plots we can draw. So box plot we can draw. Okay. And also something like hexagonal bins we can draw. So hexagonal bin plot we are going to draw. So like the different types of plots we are going to draw. And after that, once if we find that there is a outliers are there means what we need to do means we are going to check so filter outliers based on quantiles. So different types of quantiles means quarters. So every year we are having 4 quarters, right? 3 months is nothing but called as 1 quarter, right? So similarly, 1 quarter is 25%. Like that, we are having 4 quarters. Fourth quarter is 100%. Okay, that is the thing. So we are going to filter that outlets, or otherwise, no filtration directly, uh, direct approach. Okay, so direct approach. But actually, so the good content is, so filtration is more important. We are going to filter. So this concept we are going to not discuss here. Just we will draw the box plot here and we'll go to the no filtration and direct approach to the algorithm. So just we are going to check that one. So, but in our course, we are going to draw the scatter plots. We are going to filter this one using the quantiles. And after that, sir, what do you mean by outliers? You may ask the question like that. Okay. So here there is a some tourist is there. People went to the tour. So the lots of people are near to the something waterfalls. Okay, all people are near to the waterfalls, and here so they are enjoying the waterfalls. People are enjoying the waterfalls, and some people are far away from that waterfalls, and they don't like. They like, but they have a fear of this water. So that's why they are far away from this. These are called these group of people are called as outliers. Because here, if you take the waterfalls is a important attribute, then inside that important attribute, these people are very near to the waterfalls, but these people are far away from the water. So we consider them as the outliers. Okay. So that is the thing. Okay. Let's draw the box plot so that we will know everything regarding it. So here, so plot dot, so figure, so fig size, so which is equals to, I'm going to take the 10 comma 6. So that we are setting. So data dot, so box plot here and inside it. So column is equals to, so here, and for what we are going to draw means rate is there, right? He mentioned target rate, comma. So after that, so another one is here that is called as the average rate. Okay. So take that average rate and comma. So after that, so here max rate. So here it is maximum rate. Okay. So next one is plot dot show. That is the command. So it will gives the box plot. See here. So the numerical values which are having above 4,000 are nothing but outliers. These are the outliers. Okay. So these are also the outliers. These are also the outliers from the three different attributes. Okay. So that is the thing. But we are not doing any filtration, not doing anything, all these things. Okay. So we completed that task one of it. So like data cleansing. So missing values treatment, outliers, and any inconsistencies means yes, inconsistencies are there. We will remove that one also. But before that, we are going to know the correlation means finding the relation between the variables. So one variable to the another variable. So how they are related that we are going to take their color. So map which is equals to so plot dot so cm dot so viridis. So what is meant by viridis means it will use the different colors based on the numerical values of our model. Okay. After that one, so plot dot so figure and inside it so fixed size. Okay. So which is equals to, I am setting the figure size as 8, 8 width and height. And after that plot dot, so title. So we need to choose the title. So here it is, so correlation. So correlation, Pearson correlation or any name. So where y is equals to y-axis 1.05, setting that range. And after that size, where size is equals to 15. So that box size, okay. So we are going to see that. So after this one, so SNS, so Seaborn dot heat map. So where heat map is used to draw the correlation data dot so core. So means correlation it is going to take where line width. So sir, I need to remember all these commands and everything means no, don't remember all these things. But how sir, then how to work in the real time? I will let you know that how to work in the real time. Okay. So where so square is equals to true. So comma. So C map, which is equals to so color map. So after that, so line color is equals to so here. So we are going to take the white line color, and after that, so anode is equals to true. So what do you mean by anode is equals to true? Let's execute this one. So here, see that it is raising an error, exception error. So what type of exception means we need to study and we need to solve it. Okay. So here plot dot title. So where y-axis and then size is equals to so SNS dot heat map where data dot core and then so the line width maybe any spelling mistakes we need to check that. So Vmax is equals to 1 and then square is equals to so here see that this is the typo. Square spelling is mistake. SQRE. So true. C map is equals to color map and then line color is equals to white. Anode is equals to. So if you do any single mistake, it won't give. So this is the correlation. See, starting. So this blue color and then ending with so this yellow color. This is called viridis, different colors. So if the range increases, now you see that. So when the range increases from minus, from this is negative values, and here it is a 0, and then 0 0.2, 4, 0 0.4, 0 0.6, 0 0.8, and then 1. So these are completely some of the good values. Means if you find this one, see that. So the relation between target rate and also target rate always 1 only. So you versus you is always 1. Me versus me is always 1. So that is the thing. See, target rate and average rate has a very good relation 0.99 and also maximum rate is 0.99. Miles is having 0.72 and the next one is origin zip is having 0.28 and 0.15. And also similarly here average rate, target rate and maximum rate and then miles. So these are having the very good relations. He asked me to find that. So here determine the correlation between the variables in the data set to understand how they are related to each other. Identify which variables are most strongly associated with the rate based on the origin and destination. Means, so here we need to write a sentence. So what type of sentence that we can write here? So when we take that target rate, average rate and maximum rate, so these three are having very good relationship among themselves with miles also, with miles also. Okay. So that is we are going to draw and then see that origin zip and then destination zip is having 0.36 again. That is also not required for our project. And see here destination zip with respect to the miles is 0.69. Again, we are not going to consider that one. So we are going to write only one statement. Target rate, average rate, maximum rate has a very good correlation among themselves along with the miles also. Means target rate versus average rate, target rate versus maximum rate, target rate versus miles has very good relation. That meaning comes, and average rate versus target rate, average rate versus max rate, and average rate versus miles, and also having very good relation. Similarly, for the max rate also that we are going to take. This is called as something so that we are going to take. If you want to know that, so correlation, so in numerical format, correlation matrix if you want, so which is equals to, so data dot cor. So we are going to take data dot cor. So print here, so correlation, so matrix, okay, and after that, so comma, so correlation underscore matrix. This is the correlation matrix with respect to the numerical values. Instead of looking at this, so this picture represents very good clarity and gives the very good information for us. That's why analysis is more important. We call them as one of the analysis also. Okay. And similarly here, so there is another thing that is next third one. So like before going to develop this application, we need to convert that numerical category data to the numericals, right? So we are having different types of categories are there. Like here you see that. So rate source and destination state, all these things we need to convert into the numerical. But before that, feature engineering is another concept, but you don't know at this moment. So what I will do means I am going to remove some of the attributes. Okay. So after, so that data dot drop. So I'm going to remove some of the attributes. Okay. So here before that data dot, so columns. So after this one, so data dot, so drop. So here some of the columns that I'm going to remove. So origin zip is not required for me. Okay. So similarly, so destination zip is not required for me. Sir, how would you know, sir? I don't know that. So, but you know that. How, sir? You may ask that question. Don't worry. So even though if you don't know that, there is a concept called feature engineering. But during this introduction session, I can't explain that concept. And also created date. So created at. So copy this one. So created at. So comma. Page date. So these are not required for our project. So how would we know? So that will in the course learn all these things in the course. So here I'm going to remove it. So case date, so created date, updated date, all these things, comma, where in place. So in place is equals to true, comma. So axis is equals to 1. See, axis equals to 1. So in place is equals to 2. So just remove this one. So we removed. If you take that columns, data dot columns, now you see that only few columns are there. And again, check that data dot, so info. Once we need to check that one, we are having only 10 observations are there. Okay. And then integer floating point data don't touch. Just we need to convert these objects, which are in the string data. We need to convert them into the category numerical data. How we are going to convert them into the numerical data? Let's see that. First of all, we need to study that. So object, so origin category. So here copy. So data. So here there is no space, and here also no space dot. So value underscore counts. It will give that the number of values that it is having. Alsip, okay, center group, or so Alsip is 30304 times repeated in the data out of 1947 times. So this one, Alsip is 304 times in the data, and center group is 68 times in the data, and Chicago is 67 times in the data, and Laredo is 57 times. But we need to convert this complete category into the numerical. How? That is also one of the task. And here again need to check that. So this is one category, and there is the origin state is also there, right? So let's copy that origin state. So here also. So let's check about origin state also dot. So value underscore counts. So this one is also like IL 472, TX 229. We don't know that. What is meant by IL? We need to Google it. So to know that exactly complete information. And also destination city. Okay. So destination city. So data dot. So destination city dot. So value underscore. So counts. Need to check. Okay. So this is also having this one. Okay. Total 274. Again, copy it. Destination state is there, right? So destination state. Okay. And also one more thing that is called as see that rate source. So data dot rate source dot so value underscore counts. Okay. So it is having rate source 1, rate source 2, and 0. So that 0 is having, this is the complete name of it. 0 rate source 1 by name, rate source. This is the name that it has given. So there are three such things are there. So we need to convert that into the numerical. So how we are going to convert that into the numerical? Let's see that there is a concept called as a one hot encoding, label encoding, dummy variable creation, and also factorize method is also there. But first we will look into the factorize method. So here first select that data, and the first one is origin city. So origin underscore city. So this is the attribute where which is equals to pd dot so factorize. So we are going to take so data inside so origin underscore city. Okay. So after that one, so come out of it and we need to choose 0. 0 represents only one observation, that is the present, right? So that we are going to take that 0. So if I execute this one, now you see that so it is not giving any error, means here go here and let's okay, so that before instead of that one, so let's take that data dot head. So if I give that head command, now you see that origin, sorry, origin city. So you see here origin city, new attribute has been created. So this is the mistake. So then what we need to do? We need to remove that one and we need to start that one. And again, we are running out of the time. So we have the next session also. So just log into it. I will discuss continuously this concept at 10:52 p.m. AM, sorry, 10:52 a.m. I will start again next session. In the next session, so we'll continue this program. Okay, this task. It will take around 15-20 minutes in the next session. Okay. After that, we'll go for prompt engineering task, which is very, very easy. Within just a minute, we are going to get the solution. I will show you that. Okay. So please stick to it. So here I did a mistake. So instead of that, so I did a mistake. So we'll see that.